Good morning and welcome to today's lesson. Today we're going to be studying lesson 2-4, which is Algebraic Reasoning. Algebraic Reasoning, so just like the little joke here, oh yeah, I'd like to see you prove it. So that's what we always have to do in a court of law and in science is prove things. So in here, did you know that 2 equals 1? So let's just start off with A equals B. And remember, whatever you do on one side of an equal sign, you can do the same thing to the other sign and it is going to be kept even. So what we did here is they multiplied both sides by A. So A times A is A squared, and then we would get AB. Then on this side here, what we did is we subtracted B squared from both sides. So we left it the same and just subtracted B squared. Now we can factor A squared minus B squared factors into A plus B and A minus B. And on this side over here, we can pull, there's a B here and a B here. So we pull that B out, and what you're left with is A minus B. So that's what they did. Now we've got A minus B on both sides. So if we cancel this out with that, we're left with A plus B equals B. Well, A is the same thing as B, so we can call that B plus B. So now we have 2B equals B. Divide both sides by B, and you end up with 2 equals 1. Ah, craziness, huh? All right. So, properties of equality. Remember, properties of equality is when you have an equal sign and you do the same thing on both sides. So you see where we start with A equals B, and then what did they do is they added C to both sides. So in math, as long as you do the same thing to one side, you can do that to the other side. So that helps us in solving something like x minus 2 equals 5. So what we can do is we add 2 to both sides of the equal sign, and we end up with x equals 7. Okay, and now the same thing works for the subtraction property of equality. If you start with A equals B, if you subtract C from both sides, that's how we end up with A equals B. And the same thing happens with multiplication and division. Now the substitution property of equality is whenever we say something like, let's just say, oh, back in here, like where I got x equals 7. So now if you plug this back in, 7 minus 2 equals 5. 7 minus 2 is 5, and 5 equals 5. That's how we would use things to check. So substitution is putting something equal in place of something else. Putting something equal in place of something else. All of these other properties of equality, if you do it on one side, you have to do it on the other side. All right, some more properties that you guys have used very often is the distributive property, where we take something like 2 and then we say x plus 7 and we distribute this in. So we get 2x plus 14. All right, so distributing would be putting it in. So A times B is AB, and A times C is AC. And it works also when you have a subtraction sign between. All right, these properties here. So I would probably stop my video and I would get this screen copied down. The reflexive property is true just to say A equals A, like 5 equals 5. You get exactly the same thing on both sides. Well, it also works for segments so that the length of AB is going to be equal to the length of AB, and the same thing for angle measures. So the measure of angle A is equal to the measure of angle A. You see the same thing on both sides. The symmetric property is something that you use quite a bit. You'd have something like, let's just say 12 equals 2x. So this is illustrating the symmetric property. And a lot of times when you guys solve this, you don't even show any work. You guys just automatically go right to, and what do you say? You guys all say x equals 6. And I don't disagree with you, but technically in math, you can only do one thing at a time on a line. So technically we would divide both sides by 2, and now we have 6 equals x, but we have a tendency to write that x equals 6 first, and that is using the symmetric property. If A equals B, then B equals A. And again, that property works for segments, and it also works for angles. So that is illustrating the symmetric property. The transitive property is actually very similar to syllogism. So if A equals B, so if A equals 2 and 2 equals C, would we not be able to now conclude that A equals C? So that would be using the transitive property, and we're going to be using this property quite a bit here. Very similar to syllogism. All right, so we want to solve the equation, and you're going to justify each step. And we typically do this writing 2-column proofs. And so that this side over here is the statement. This is what you're giving, statement. And then we're going to give the reason as to why we can do that over on this side, and that's why it's called a 2-column proof. So we're going to go through statements and then reasons. And all those properties that you just wrote down, whether it's the addition or the subtraction or multiplication or reflexive or transitive, all of those properties are going to be your reasons. Now, 90% of the time, 95% of the time, the first step is just going to be given. Occasionally, we get our information from a diagram, and then it might be something else, but a lot of times it is given information. And we like to label our steps. So step 2, what I would do next to solve this is I'm probably going to take -5 times 7 and get -35W. Take -5 times 8 and get -40 equals 30. So a lot of us are probably going to distribute for your next step. Okay, then I'm probably going to add 40 to both sides. So a lot of you are going to write +40, add +40, that's fine. So -35W equals 70. And what did we do to both sides? We did the addition property of equality. All right, and now for the next one, most of you are probably going to do division because you're going to divide both sides by -35. And when you divide both sides by -35, we have W equals a -2. All right, so that's one way. Some of you may have done this different. You may have divided right away, because maybe you divided both sides by -5. And if you did that, you have 7W plus 8. And if you divided this by -5, you'd have a -6. Then some of you are going to now, in your next step, you are going to subtract, because you're going to subtract 8 from both sides. So you have 7W equals a -14. And then now you're going to divide both sides by 7. And if you divide both sides right now by 7, you end up with W equals -2. Now, both of those work. You can do distributive addition, division, or divide, subtract, divide. Either way, you are justifying your work. So in your homework today, there's going to be a lot of different ways that you can do some of these problems. All right, here's another kind of property, and we're going to be doing angle measures this time. So we've got statements and reasons. I wonder if I can move those up a little bit. Oh, I've got all the work there. I did not know that was there. Okay, I'm going to actually just write it out. So in the first step, I can see that this diagram says that angle 1 is congruent to angle 3. And how do I know that? Because they're both marked with single marks. So I'm going to say that that is given information. All right, now they want me to focus on an angle DBA. DBA. And they also want me to focus on an angle that is EBC. So they want me to somehow, some way, get those angles equal to each other. Well, let's see. Don't I have a property? So you probably should have stopped the video. You should be giving this a try. And then when you think you have some kind of proof or statement and reasons done, then you can go back and resume this video. So please make sure that you're giving this a try. And then you can go back and play the video and you'll get your solution here. So now that I have angle 1 and 2, I'm going to say angle 1 plus angle 2 is going to be equal to angle 2 plus angle 3. What did I do to both sides? I did addition. I did the addition property of equality because because what I did is I added angle 2 to both sides. All right, in my third step now, we had something back in lesson 1-2 that said we could take angle 1 plus angle 2 equals angle, what's that? 1 plus 2 is C, B, E. And can't I also say angle 2 plus angle 3? Angle 2 plus 3 is going to give me angle D, B, A. And what is that called? That is called angle addition. That was the angle addition property. I don't know if that was from lesson 1-3 or something about that. Well, now what do we have? 1 plus 2. Well, right here I have 1 plus 2. So now, instead of writing 1 plus 2, can't I write angle C, B, E? Isn't that what the substitution property of equality is? All right, and now instead of writing 2 plus 3 right here, isn't 2 plus 3 equal to angle D, B, A? All right, now technically up here in the proof, they have the DBA first and not the, so I should do one more step and then I should call that the symmetric property. Okay, I don't have quite enough room. I'll just squeeze it in here. Angle DBA is equal to angle CBE, because technically up here, the way they have it written, they have the DBA first and the EBC. Now, I don't have to change my letters. I wrote CBE and they have EBC. Now remember, those two name the same exact angle, so I don't have to worry about those letters being exactly the same because they mean exactly the same thing. Okay, so this is the big idea. Given, then we're going to add 2 to both sides, then we used angle addition, then we substituted that value in, and then I finally had to use symmetric to get those switched. All right, good luck on your homework today on lesson 2-4.